Hello class, this is just continuing on from the previous video, how we saw that data can be separated into two main groups, categorical and numerical, and each of those can be further divided into nominal categorical, ordinal categorical, or discrete numerical, or continuous numerical data. Let's get into a few examples here. Now, with a few of these examples, some could argue that it could be the other kind, right? But it really depends on the method in which you are measuring these. You'll see what we mean in these examples. So classify the following data as categorical or numerical, then further classify each as nominal or ordinal if it's categorical, or discrete or continuous if it's numerical data. So let's get straight to it. So the number of students in a classroom. Well, if you were to measure this, or count this rather, it is definitely some sort of number. So this is numerical data. And as you saw in my previous video, when it comes to counting individuals, it's impossible to get 0.5 of a person or 0.5 of something that you're counting. So the number of students in a classroom is a discrete numerical data. The most watched Australian TV show. Well, definitely the results from this is some sort of category or some sort of description. So this is definitely categorical. And if we consider the results of this, let's say we had Who Wants to Be a Millionaire, Who Wants to Be a Millionaire, or I don't know, Channel 7 News, Channel 7 News. There's no order in which we can put these because one is not greater than the other. So this can't be ordinal, which must mean that this is a nominal categorical data. The heart rate of people. Well, this is definitely dealing with some sort of number because it's beats per minute. So this is numerical. And now here's the difficult part, because depending on who you ask, from my research, from my understanding, you cannot possibly get half a heartbeat. So I would argue that this is a discrete numerical data. However, I have seen devices that measure beats per minute in a person once you've attached to them, and I've seen it as 162.5. I've seen it sometimes as 180 something, 0.0 something. So because of that, put a little asterisk here, it might be considered a continuous numerical data. But I would personally continue to argue that it's definitely discrete numerical data, simply because you can't get half a heartbeat. Right, moving right along. The mode of transport taken to work. So if you ask people, how did you get to work? The types of results that you get will be they won't be numbers. They might tell you, I walked to work, I drove to work, etc. So this is definitely categorical data. And walking, train, car, bike, none of those can be put in any sort of order. So this is not ordinal, so it must be nominal data. What is your level of education? Well, like before, the answers to this sort of question are not numbers, so it must be categorical. Now, we can definitely get some sort of order of education, because the order in which that we get educated is primary school, high school, college or university, and possibly even further studies. So there's a definite order to education. So this must be ordinal categorical data. How many hours do you spend on your phone per week? Okay, so now this is pretty tricky. This is definitely nominal. Okay, now here's where it gets a little tricky, because hours, right? We could spend half an hour, quarter of an hour, 0.2 of an hour. You could argue that this is continuous numerical. However, if given a survey like the following, let's say you were given a survey like this, where they asked you to tick a box, and they said this is less than 1 hour, 2 to 3 hours, 3 to 4 hours, greater than 4 hours. If you were only given these sorts of options, you could argue that this is a discrete numerical data. So depending on the circumstances of these questions, this might be considered discrete numerical. Nominal. Discrete nominal. Oh, spelled that one wrong. It should be numerical. I just realized I could just copy this. There we are. Copy this again. There we go. The average number of students per classroom. Now this might seem very similar to this first one here, the number of students in a class versus the average number of students per classroom. Now, by adding that word, the average number of students, okay, per classroom, we may take the total number of students in a school divided by how many classrooms there are. Now, because that we're dividing the total number of students by the number of classrooms, it is actually possible to get in between numbers. Okay, so this is definitely numerical, but because we're dealing with a average, it is now possible to get a continuous degree of numbers. The distance walked by students to their next lesson. Well, you could walk 5 meters, 5.5 meters, 5.2 meters. So this is definitely continuous. I'm just going to copy this one. This is definitely continuous numerical data. The height of students. Well, if you're going to be measuring using some sort of tape measure, it is possible to get a varied degree of accuracy. So, just as before, this is continuous numerical data. And last example, the daily average number of cars sold in a month. Well, I hope the idea or this wording here, the average, gives it away. This is going to be a continuous. I'm just going to copy the previous one as well. This is a continuous numerical data. Just as a point of comparison, if the question or what's being counted was, say, the number of cars sold in a week, if that was the question, this would have to be a discrete numerical data because it's impossible to sell half a car. But compare that to the daily average number of cars. So I hope that gave you a deeper insight with these examples on continuous or discrete numerical and ordinal and nominal categorical data. Hope to see you in the next video. Best of luck.